Today we're actually going to be doing a demo. We've worked closely with PennyLane on the Amazon Braket side. And so in today's demo, I'm going to briefly go over Braket, show you guys some of the service dashboard, how that experience looks, and then actually dive into two examples. The first one will be around hybrid jobs, which is our quantum classical compute runtime. And the other will be, if we have time, of VQE, the VQE algorithm, and showing how you guys can use Amazon Braket and PennyLane together. So just to level set, go over quickly, Amazon Braket is an AWS service. It provides customers, developers, researchers, everyone access to different types of quantum computers. It's a fully managed AWS service, and you can see that we have different types of providers as well. We have ion trap machines, we have superconducting, as well as AHS or analog Hamiltonian. And it's pretty important in this early stage that we have access to different types of quantum computing devices because each of them has their own characteristics. So what I'm sharing right now on my screen is the Amazon Braket dashboard. If you have an AWS account, or if you are in the process of creating an AWS account, when you go to the Braket homepage, you'll see a dashboard, has a bunch of announcements. You can see the devices that we offer, when they're available, and then you can also get specific information about them. So this is an IonQ device. You're able to see the topology as well as specific calibration information. But today we're here to talk to you about PennyLane and how you can use it with Braket. If you go to the PennyLane website, you'll see that there's a bunch of demos. In the demo section, there's a specific area for devices and performance. And today we're going to be going over two demos. The first is around hybrid jobs, and the second is VQE. Within the past 6 months, we've actually worked on something pretty cool with PennyLane. In the right-hand side, in addition to seeing contents, for select demos, you'll actually see a run on Amazon Braket hardware button. And so with this one or the VQE one, when I go ahead and click on it, it brings me up to this pop-up. You can see that there's a custom Braket PennyLane plugin, but then we can also visit the GitHub or sign up for Amazon Braket. The Amazon Braket and PennyLane plugin essentially translates PennyLane code and makes it consumable by Braket. It's fully open source. We welcome any contributions, and you can actually see us actively developing it. There's open issues for the community, as well as the source code for you guys to look at. Additionally, for each one of these demos that we have, when you click Visit Amazon Braket GitHub, it'll take you to that specific example that you can play around with, run locally, or on Amazon Braket. So let's go back to the first demo, getting started with Braket hybrid jobs. PennyLane does a great example of showing you what is hybrid jobs, how does it work, and then actually providing you that source code. But what if we want to take it a step further and actually run this on a quantum computer or on a quantum simulator? With Amazon Braket, you're able to do that and go that extra step. When you go to our Braket console and you click on notebooks, you can see that I've created some test notebooks. If you don't have any notebooks, you can go ahead and create a notebook. But since I already have one, I'll actually just go ahead and click on that. In a new tab, it opens up our Jupyter Lab IDE. Inside of this IDE, we've already pre-imported all of the PennyLane libraries and these demos that you can access. So if I go back to this, you see I have this first one opened up right here. On the left-hand side, if you're coming to this from scratch, we have a file repository where you can see examples, you can see all of the PennyLane examples we have, and getting started features as well. But for today's demo, we're going to focus on a hybrid job. And what is a hybrid job? For those familiar with quantum classical algorithms, we know that these variational algorithms do best when there's an element of quantum processing and classical processing. But at times it can be cumbersome to maintain these. And so Amazon Braket hybrid jobs is the runtime environment that we use to actually manage the orchestration of these type of variational programs. In this tutorial and in this demo, not only do we tell you what Braket hybrid jobs is, but with a single line of code, we can show you how to use a PennyLane simulator to run a full-scale experiment on a quantum device. So I'm going to go ahead and get this running. while it's running in the background, I'll chat. Let me actually restart the kernel and run all cells. So we're starting from scratch. And the best part is, this is that exact example that you see on the PennyLane demos page. But in our Braket notebook environment, we've actually gone ahead and taken it a step further. If I scroll to the top, I can see, hey, intro to Braket hybrid jobs, and then get started with PennyLane. You notice that all the standard Python imports for PennyLane, importing the QML device, and we're going to actually build a basic circuit. 2 rotation gates, and we're going to be measuring the expectation values. So from Braket hybrid jobs, we're importing this, we're building the circuit out, and then we actually run the algorithm. But how do we run it as a hybrid job? We recently launched this thing called jobs decorators. Essentially, it's a Python decorator that allows you to take your hybrid job and put it in the form of a function or a Python decorator. I do all of my standard imports. I have my circuit here. And with this decorator at the top, I'm specifying the local device. I have something called local mode turned on as true right now. This is just for debuggability purposes, but if I remove it, I can actually run it in my notebook environment. When I enable it, I can actually go and see, hey, if there's any debug issues or if there's any issues that I have in my programming, I can actually go and, deep dive into those. I've already pre-ran this circuit, so you'll start seeing, because I have local mode enabled as true, it's logging in, it's actually installing Docker, doing all of that stuff, but I've actually gone ahead and completed this. Takes a couple minutes, maybe less than a minute to run, especially since I'm doing this on local mode. But one of the things that I notice is I can get the job results. I can view these job results in my notebook, or if I go to the Amazon Braket console, I can actually see, hey, I've ran these 2 just now. I can see the specific tasks that I've ran, as well as the hybrid job. When I click on that hybrid job, this is a qubit rotation example, I can actually view these results in a graphical interface as well. So I'm able to see any events, when did it start, when did it run. I'm able to look at any monitoring metrics to see the number of iterations we went through, the expectation values for each iteration. And then if I want to create any tags, I can do that as well. If I prefer to do it locally in my Jupyter notebook, I can get all of these results programmatically as well. But for those customers who want an option to actually go and see the visual element, do some more debugging, see the source code, the number of steps, specific hyperparameters, save it to an S3 bucket, I'm able to do that as well. If I keep scrolling down, I can see those simulator results that I mentioned earlier in the console, the iteration number, and then the corresponding expectation values. The best part about this is I can also run it on a QPU directly. So when I go to the PennyLane demos page, I see all of the code. I can see that I run it on a local simulator, but I want to take it that one further step. I want to actually run it on a QPU. And so here, you specify the device ARN. So IonQ is one of our partners, and they provide us their ARIA device. I can actually go ahead, take that same code, and just change this Python decorator to say, hey, instead of running it locally, now I want it to point to this device ARN. Once I do that, I'm actually able to go ahead and check, hey, where is it? Where in the queue does it stand? How long will it take? So if I go back to the console and I click on devices, it might have already ran. I can see that there's one job running in front of me. So let's see if it's actually ran or if it's in the queue. It seems like it's still running, but I'm able to actually go and see through the Braket console that, hey, my job is running. Getting that visual element sometimes helps reinforce that, hey, it actually submitted, it made it through. And so while we wait for this algorithm to complete and download the result, let's go ahead and look at the other example that I was talking about with the VQE. Again, on the PennyLane demos page, there's a brief overview of VQE. Again, going through that point, I can look through this code. I can see, hey, what is a VQE? How do I use it? How does it work? But if I want to take it that further step, I can click on that run on Amazon Braket. I can view the source code in GitHub. And then I can also go to my notebook and actually run it. So if I go over to the file explorer, I click PennyLane, and you'll see, actually, let me expand this. There's a bunch of examples here. If I click on the hydrogen molecule geometry one, it'll open it up in a new tab. And then I can actually run this as well. So it's going to start running, but let's walk through this and see how this actually works. So what are we trying to do in this example? We're trying to use VQE, an established variational quantum algorithm, to solve a chemistry problem. In this case, it seems like we're working with the hydrogen molecule and trying to simulate some certain characteristics about it. I can see that in my notebook environment, it's already started going through, it's pulling PennyLane data sets, and we're defining an ansaz. When it comes time to measuring the total energy and the spin of it, I can write my code, again, pulling from that PennyLane example, but we're using that Lightning qubit simulator here. Scrolling down, we can see that, hey, we've gotten a result. Now we're minimizing the energy, trying to get that optimization. And this goes to give us this result. So we can see how many steps, again, the energy. If I go back to my device console, I'm able to view in the hybrid jobs tab. So this one is running right now. I can see, hey, ran large VQE simulation. Let's go and look at the events. This is when it started. This is when it ended. I can monitor those results and see, hey, how many iterations did we do? So in that code, we set the number of iterations to 29. And here's the energy levels at each one. I can see any tasks associated with it, as well as define any custom tags. Again, for those of you who want to stay in the notebook, you can view all of this data here as well. Same graph that we saw, but how can we scale this up? How can we run it on, how can we run it on a classical instance to a larger instance? And so let's use this hybrid jobs function that we were talking about. Again, we have that Python decorator where we specify the Python, or the device, and then we set up an instance config. So this is using the power of AWS and any existing compute that we have and saying, hey, this is the device, this is the configuration, and let's go ahead and run that. You can see it's just a function that we've defined previously. Again, when I go through that, I'm able to see, oh, we've gotten an error. We won't do any live debugging, but you're able to see that, hey, this is the quantum job, and then these are the result times. The CPU times, the wall times, and then you can actually plot the results. This is how you know it's a live demo, the joys of any live demo. But ideally, we would have the graph outputted here. We can change the number of shots as well. With any good variational algorithm, you want to be able to customize it, play around with it. And again, as this demo illustrates, you're able to do all of that in the scope of Amazon Braket from the existing PennyLane demo. I'll pause there. I think there was 15 minutes for demo and then about 5 minutes for Q&A. So happy to take any question and answer. And maybe by the end of the Q&A, this will have finished running. So.
Yeah, thanks, Zia. As with the other AWS talk today, your little AWS minions in the chat have answered everything. So, yeah. So if there is something more you want to talk about, floor is yours. Otherwise, I have some questions. But yeah, up to you.
I think, yeah. Before we get into some of the questions you have, I think the two things that we really want to highlight. The first one is the ease of getting started. And when you go and see a bunch of demos, you always wonder like, hey, this is great. I can run it locally, but what would it look like on an actual quantum computer? How would I do that? And right now you'd have to download the code snippets. You'd have to go and find the source file, make sure it works, upload it to the cloud. And so we've simplified these steps for customers. We have it on a select number of demos right now, but we've started increasing that number. And allowing customers to directly run things on Amazon Braket kind of eases that user experience. The second thing that I wanted to point out was this hybrid jobs decorator. So being able to run a hybrid job has been simplified down essentially into that one line of code. So here we've set that hybrid job Python decorator, if you're familiar with that concept. We set any parameters here, like what is the device name? Are we using local mode? Are we not? And then just have your regular function, and you're able to rotate this out for different devices. Let's say I want to use a Rigetti device or a different device. IonQ has another machine called Harmony. I'm able to type that in, run that exact same experiment, and reproduce my results on different types of quantum computers and different types of topologies as well.
Cool. All right. Well, if there are any questions for Zia, please put them in the chat. Okay, we have a question from Panos Const. Are hybrid jobs equivalent with sessions in Qiskit?
Yeah, so a good way to think about hybrid jobs is, to what I was saying earlier, it's if you're trying to run a variational algorithm that needs some classical compute and some quantum compute, and you're worried, oh, hey, how do I do that orchestration? How does that work? Hybrid jobs does take care of that for you, similar to what you'd expect in your current experience. And not only can you do it programmatically through the Braket SDK, but you can also do it through our UI interface. So if you want to create a hybrid job, and let's say you don't want to mess around with notebooks, you can do this all through our UI. So you can say, hey, what is my hybrid job name?
Oh, that's cool.
I can actually upload my algorithm directly, or I can specify an S3 location. So if I'm already using AWS and I have all of my stuff there, I can just point to a single S3 location. I can choose what container I want. So we have existing containers that have TensorFlow, PyTorch, or I can bring my own container as well. I can specify the device. So we can see that we have, Rigetti device, Amazon Braket simulators, or embedded simulators. So this is where I would use, PennyLane Lightning or maybe some NVIDIA simulators. I'm able to actually select, hey, what kind of classical compute do I want? Do I want standard? Do I want it to be compute optimized, GPU optimized? Set the number of gigabytes of RAM. I can even set stopping conditions. So let's say I'm not sure how long my, variational algorithm will take. I can say, hey, please stop it after this many seconds or this many hours. An additional thing you can do is checkpointing, and I'll get to that in a sec too. But you can set hyperparameters. So if you guys were paying close attention to my demo, we had set some hyperparameters as well in some of those workloads. But as I'm going through these iterations in these variational algorithms, I can actually save data at specific points. And I can point to an S3 bucket that says, hey, after 1 iteration or 10 iterations, please periodically save my data. And then I can also output that data configuration to a specific S3 bucket. So I know that's a little more information, but figured since we were on the topic, I would also show you this user-friendly UI to emulate.
That's really cool. I didn't actually know that was there. I made that video a while back about hybrid jobs and stuff. That link's probably still in the chat. You can scroll up. I kind of did it all like the manual way, like just actually writing all the code. I didn't know that
like
this
programming
existed. Yeah. I didn't know that this existed. That's really cool. All right, Zia, we'll have to leave it there, but you will be in the Discord. So if people have any questions for Zia and the AWS team, feel free to head over there. It was really great to have you today. Hopefully you're able to find some cool ice cream in New York. I'm sure there's a place. I'm sure you know a place. Always. All right, Zia, take care. Lovely to have you at QHack. Thanks for being our final talk today. Really appreciate it. And have a great rest of your day. Cheers.